Hello, everyone. I am Nicholas Downing. I am absolutely delighted to be here today. It is an honor, and thank you so much, Patrick, for hosting and for having me join. So I have been a full-time blacksmith for about 5 years now, and I have been involved in it in some capacity for about 25 years. So I've been around, and I think ever since I started blacksmithing, I was always particularly interested in objects that were functional and not strictly, sculpture or decorative, but, everything from, kitchen tools to, some hardware and a little bit of architectural work. But my main interest, my main sort of passion has always been edge tools, and foremost among those are axes, because I just think that they are a beautiful combination of form and function. So I know that not everyone here, English is not necessarily your first language, so I wanted to start by just getting into a little bit of terminology, so we're just all on the same page here. So for our purposes, I mean, axe is an incredibly nebulous term. It can mean, something from, say, an American tomahawk to, something like, one of these Finnish hewing axes. But for our purposes tonight, let's kind of back that off a little bit. And so I'm talking about, something that is suitable for, felling a tree, or doing some camp chores, cutting up some kindling, et cetera, et cetera. So, and the pieces of the axe that as I understand it, is, sort of anything forward of the eye is the blade. And then this sort of last little bit that is the cutting edge, we call that the bit. And on an axe that has been sharpened already, this last little plane here, I call that the bevel. There is, of course, the eye where the handle goes. And if it has any sort of extra mass on the back of the eye, I call that the pole. And then if it has any sort of protrusion that sticks out sort of past the eye, past sort of the profile of the axe, we call that the lug. And then, of course, the side of the eye, that is called the cheek. And then if I show anything tonight where it's more than a bar, but it's not yet a finished axe, I'm going to refer to that as a preform. And then beyond that, I'm going to kind of break down axes into some broad categories. First of all, there are monosteel axes, which is an axe which is made from a single piece of steel. So the whole axe is forged from a single piece. And then I will, if axes are built up from multiple pieces, or like this one, this was punched out of a single piece of steel, but then it has a high carbon steel bit that's going to get inlaid and forge welded into the edge. So I call that either a composite axe or a laminated axe. Just so we're all on the same page about that. As far as tooling goes, I think that's a really critical aspect of any sort of blacksmithing project. When you're starting out, it's good to know what you need beforehand. And as far as layout goes, the things that I find really helpful are a nice pair of dividers. What I like about dividers is that they are very, very accurate, and there's no math involved. So if I'm, trying to find, say, the center of a bar, I can just adjust my dividers, and find dead center pretty easily. You can, of course, use a ruler too. But for me, even if I'm doing my layout with a ruler, I tend to go back and check all my measurements with a pair of dividers, just so, if I'm doing, say, a wrapped and welded axe, I can, make sure that my cheeks are the same length, things like that. Similarly important for any kind of layout work is a center punch. And then as far as the actual forging goes, I can't stress enough the importance of having really well-fitting tongs. So these are tongs that I made specifically for forging axes. They come in handy for all kinds of other things too, but just having those stubby curved bits, they really allow me to get a very strong grip on the pole of an axe, which is really important for safety and for control, and and I think accounts for a lot of my success when forging axes. Also got another pair that I like a lot. I did not make these; these were given to me, but they're really great for holding the bit, and it's the same kind of thing. You really have to have that firm grip for whatever you're doing. And then, so if we're talking about a monosteel axe, a punched and drifted axe, it's really nice to have some sort of cutter. This is a hot cut. This is one that would be held with a pair of tongs. And what I want to sort of note about it is that it doesn't have a very pronounced bevel. Everything is kind of rounded, and it's sort of lenticular. It's rounded on both top and bottom faces. And the idea is that all of that means that there's very little friction when you're hammering that into a bar of steel. So that's very handy. This is a very essential tool for axe forging. I will alternately refer to this as a drift or a mandrill, depending on what I'm doing. I think of a drift as something that is hammered into a hole to enlarge it, and a mandrill as something that shapes a hole. So this can be used for either. This particular example is made from, I believe, H13 steel, so it's a hot working steel, so it's suitable for drifting. It's suitable for hammering into a bar of steel and enlarging it, but I can also use it on, say, a wrapped and welded axe to just make sure that the eye is the correct shape. And then I'm going to get into these in more detail in a little bit, but another tool that I find really handy for axe forging, especially for wrap and weld axes, which I'm going to talk about at length, is some top fullers. So these are handled tools that you strike, and of course have a rounded face. So as I mentioned, I sort of break down axe forging into two broad categories, and those are punch and drift and composite or laminated axes. And so a punch and drift axe is just exactly what it sounds. That's when you start with a solid bar of steel, presumably of appropriate alloy. You can see I have a little note to myself that this is a bar of 4150, so it's got chromium, molybdenum, and a sufficient amount of carbon to hold an edge. This would make a decent axe. All you have to do is punch a hole in it. As far as actually punching the hole, the best advice I can offer is that if it's a fairly short axe, you can probably just go right to town with the same punch you would use on, say, a hammer. If it's a somewhat taller axe, I would recommend that you start by drilling a series of holes in the center all the way through the body of the axe, and then coming back in with your cutter and sort of cutting the webbing in between those holes. That's going to save you a lot of time, and having those holes accurately drilled all the way through the bar will also prevent your cutter from racking and either coming out the side of your billet or or having one cheek that's very, very thin and one that's very, very thick. Of course, there's a little bit of fiddling that can be done afterwards to account for that, but it's really much easier to have those holes drilled. The other thing that you're going to want to keep in mind with a punched and drifted axe is that, because you're putting so much effort into punching that hole, chances are the pole of the axe is going to shrink somewhat. You can, to some degree, upset that and get a little bit of that height back, but it's certainly something to be aware of. If you want a very specific size of your axe pole, then you should be sure to start with a taller bar than you're ultimately going to end up with. All right, so that's that's kind of my spiel on punched and drifted axes. I really want to spend the majority of tonight talking about, if I'm being honest, what is my favorite technique, which is, composite axes or laminated axes, axes that are made from multiple pieces. Um, as I mentioned, just because an axe is punched and drifted, it doesn't mean that it isn't a composite axe. But I want to focus the majority of my talk on axes that are built up from multiple pieces, and so I'm going to spend some time talking about the wrap and weld method. So if you're not familiar, I know probably most of you are, but theoretically that starts with bar steel, and you lay it out, you make your center punch lines, and then you fuller into it, and the two ends become your blade, and then the little material that's left on the back there becomes your pole, and and at some point in the process, the bar actually gets folded over, and high carbon steel bit gets inserted to forge the blade. So why do I like this method? Why? I mean, I said I kind of unashamedly choose favorites here, and I really enjoy the process of a wrap and weld, of making a wrap and weld axe. I think it's um, it's a little more technical. I really enjoy the forge welding part of it. And, there's something kind of magical when you take this bar and you fold it in half, and all of a sudden it starts to look like an axe, and then you heat it up to within an inch of its life, and smush it together, and it fuses, and you get this this thing. It feels like you're sort of crawling inside it, or you're kind of appreciating the making of this thing on another level. Now, another reason that one might choose this method over, say, a punched and drifted axe is that it conserves a lot of high carbon steel. And that gets to, another aspect of why I like this method, and that's that there's a lot of tradition. Since the dawn of ironworking, the nature of the material was that it was rather coarse compared to modern mild steel. It was wrought iron. It wasn't mild steel, and wrought iron has grain, much like wood. And if you were to just punch a hole in it this close to the back of it, there's a very good chance that it would split. And so it actually made much more practical sense to start with a bar and wrap it around. But and that's all the steel you need to make an axe of a moderate size. And steel was a precious commodity. It was it's easy to take for granted these days, because it's everywhere. It's skyscrapers and it's cars, and but once upon a time this was very, very precious. And I kind of I guess I'm a bit of a romantic, and I like that history. Another reason that I think I prefer the wrap and weld method is because I think it, as a smith with a fairly minimalist shop working alone, I'm able to make much larger axes when I'm making them in pieces. I showed this one earlier. This is made from 5 pieces of steel. So is this one. This is the one that was actually in the advertisement. This one weighs almost 3 kilos. So it's over 6 pounds. This is sort of a Scandinavian style hewing axe, and I'm sure there is someone out there that could make that from a single piece, but it's not me. So this is built up from 5 separate pieces of steel. So there's a democratic aspect of making an axe from multiple pieces. Now, interestingly, I just had a client reach out to me who was interested in buying one of my little camp axes, and they said, like, "Oh, I see that it's wrapped and welded. Is it going to be strong enough?" And I was kind of taken aback, and I had to think about it a little bit. And my answer, of course, is yes. I take a lot of pride in the cleanness and the tightness of my forge welds, and I'm certainly not worried about it splitting or becoming delaminated in regular use. But it kind of gets to a bigger question of, is a wrapped and welded axe as strong as a punched and drifted axe? And what I would say is, as far as if you're subjecting it to, if you're subjecting two axes, let's say, they're about the same size and shape. One of them is punched and drifted and one of them is wrapped and welded. Is one going to be as strong as the other? Probably ultimately not. But would it be sufficiently strong? And I would say yes, absolutely. So I would use this as a metaphor. This is a poor drawing of two knives that are basically the same size and shape. One of them has a rat tail tang and one of them is full tang. And both of those are valid approaches. If you take the blade and you put it in a vise and you start adding weight to the handle, will one of them break before the other one? Yeah, probably. But will they both function as knives? Yeah, absolutely. A knife isn't a crowbar. And then sort of, just you get it, I think, at this point. But I just want to really drive this home. So one aspect of my business is that I also do a lot of repairs on antique axes. This is one that a client just sent me, and you can see that the eye has been very badly pooched out here. And so you could argue that, like, yes, this axe failed, but they weren't using it as an axe. The reason that this looks like this is because at some point the handle got loose and somebody took it off, and then they were using it to split firewood by jamming this in the top of a log and hitting it with a sledgehammer. And so, like, yeah, it failed, but it was being used for something that it wasn't intended to ever be used for. So so I maintain that if done properly, a wrap and welded axe is absolutely up to the task of generations of use. So I'll get off my soapbox with that. So, so as I said, it's sufficiently strong if it's done well. So how do we do it well? Well, I think the most crucial aspect of a wrapped and welded axe, I'm gonna get really close to the camera with this, and this is a wrapped and welded axe, by the way, and there's no funny business here, is that you have to have a really clean, tight forge weld going all the way from the tip of the eye to the where the bit steel is added in. And how do we achieve that? Well, part of it goes all the way back to layout. We want to make sure that everything is really, really accurate. We want to make sure that when we get to this point, when we get to the point at which we're ready to fold it in half, that everything is precisely the same length, because we want, when we fold that together, we want that those two pieces to come together perfectly centered. We don't want one to be one side or the other, because that'll throw it off and you'll create a slip plane there, and you're likely to not get a perfect forge weld all the way at the end. So that's one aspect. Another aspect is that when we start with our parent bar and we fuller into it, there's some metal that gets dragged into that fuller mark. And you can see that. You see how much light there is. There you go. You can see that, in addition to, of course, the fuller, which, isn't going to be tight through the ruler anyway, but that it kind of slopes into that. So there's kind of an overlooked aspect of this, which is that once you get to this point, it's really important to go back and upset that little shoulder. So I clamp this in a vise, and I come along here and I give it, a heat or two, and just try to make sure that I have a sufficient amount of material. So you can actually see now that this little edge is sticking proud. And that gives you just that extra little bit of mass, so that when you go to forge weld that together, there's plenty of meat there. So that, and the other sort of aspect of that is that, if I've got two axe eyes drawn here, if your axe eye ends up looking like this, after you forge it, as opposed to like this, which is, kind of what we're after. Um, when you go to insert your drift, when you put your shape into the eye, that blade is going to kind of act like a fulcrum, and it's going to be very easy for that weld to start to open up. Versus if it comes together, and it's almost perpendicular at the front of that eye, the forces are going to be pulling rather than prying. And that's going to give you a much better chance of that weld staying strong. So both of those are sort of structural approaches. Here's another one. So, this is pretty heavy stock. This is 1.5 by ½ inch, or this looks like 12 millimeters. This is somewhat thinner. This is only about 9 millimeters. But I started, the pole in this one gets built up by forge welding a piece to the inside of the bar and then wrapping around it and then adding another piece. So that's another way to sort of build up a sufficient amount of mass to really make sure that you have enough here to get a nice heavy, blade at the base of the eye and have a sufficient amount of material for a really tight weld. Okay, so all of those are structural approaches. There's also a metallurgical approach to getting, an extra tight eye when you're doing a wrapped and welded axe, and that is to get some high carbon steel into your weld boundary. And you can do that a couple of different ways. Here's two examples. One way to do it is to run your bit steel, the steel that you're using for the edge of your axe, all the way back to the front of the eye. It's a totally valid approach. Another approach is to have some sort of little high carbon steel shim at the the base of that weld. And so I get this stock. This is 1075. If you're in Europe, I believe they call that C75. And so, this would be about the right size to stick in that weld boundary. And, for whatever reason, I think it's because high carbon steel has a lower melting temperature than mild steel. It seems to bond better to the mild steel than the mild steel bonds to itself. So that's my other trick for making a really tight weld. Another couple of options are you can, if you have access to it, if you can find it, wrought iron, real traditional wrought iron, not mild steel, also leads to a stronger weld. It's very pure. It has very little alloy. It also has a lot of silica slag, which makes it self-fluxing. And because its welding temperature is so high, it's almost melting. And so so this axe that I have been using all along, this is actually made from wrought iron. And, I'm able to get a very clean, very tight weld just by virtue of the fact that, I'm heating it up quite a bit higher than I would be if I were using mild steel. So those are my tricks for getting a very tight weld at the base of the eye. Another sort of aspect of this that I like a lot is to, before I fold it, I start to feather my edge. Regardless of whether you're doing a wrap and weld or a punch and drift, theoretically at some point you're going to have something that looks like this. And if you have that material started when this gets folded, you've already got a nice cleft in there to insert your high carbon steel. Now, I don't take this all the way down to a very thin knife edge. I want to leave some meat on that because it's very easy to overheat that, and that creates a lot of ugly, some very deep, crusty pockets, and all of that can lead to a poor join when you go to insert your edge steel. Now, as far as the actual forge welding process, so I'm working in a solid fuel forge. I work in coal, so if you happen to be working in propane, you may have to adjust some of this. But I find it's really, really important to bring everything up to temperature very, very slowly. Also, when I am at the point where I'm ready to insert my high carbon steel for my bit, I usually have this preheated almost to the welding temperature, and this goes in cold. Also, whenever I'm doing any welding, I like to have all of my surfaces ground down to bare metal. You can see that, this was forged and there's still a couple little like divots in there that I have to finish grinding out. It's not that I'm worried about the mill scale, the iron oxide on the surface, but what I am worried about is these little pits can trap scale, they can trap soot from the fire, and all of that can lead to a lower quality weld. So, having this ground down to bare steel, having these two surfaces ground down to bare steel will increase the likelihood of a good weld. Um, Obviously, it's not really possible to get in there to grind this down to bare steel, but you will see that I have some flux on there already, and one of flux's purposes in this case, I think this is just borax, is to lower the melting temperature of the iron oxide. So once I had finished my cleft, either by chiseling into it or cutting it, or just from folding it and thinning it down, I would take this and I would preheat it to, a nice dull red, and I would sprinkle some flux on there, and then I would heat it, kind of pretty close to the welding temperature. And I would take a wet wire brush and I would scrub out that cleft really, really well. And that really gets me right down to bare metal. Now, if you're having any trouble holding that bit steel in, there's another little trick you can do, which is this is a pretty steep but sharp little chisel, and you can actually sort of chisel into that at an angle. And I go one side and then the other, and I can raise some little teeth on that. And then so this comes out of the forge. It's already almost at a welding temperature. This is cold, and I jam that in there, and then I hammer these lips down onto it, and that will anchor it in there so it won't just fall out when you go to put it back in your fire. For me personally, I like to leave my bit steel not much longer than I really need it to be. I've seen videos and things, and sometimes people have whatever 1 or 2 centimeters hanging out on both sides, and I really don't see the point of that. In addition to just sort of being wasteful, it also strikes me that that steel is very prone to melting and burning. And of course, when high carbon steel is close to a welding temperature, it can be quite brittle. And having that sort of hanging out in the fire unprotected can mean that you can burn those ends off, which is obviously not desirable. So, and then the other thing is that if you like me are working in a solid fuel forge and you have those long ends hanging out there, when you go to pull this out of the fire, it's really easy for those long ends to snag on something and pull your bit out of the fire. So yeah, you want to have a clean, deep fire. You want to have, you want to bring everything up to temperature very slowly. You want to preheat all your mild steel before you add in your high carbon steel. You want to use a good quality flux. And then, regardless of whether you're starting with this weld at the base of the eye, or if you're if you're adding your high carbon steel, you want to do a lot of light, quick blows. And I really like the ball face of a rounding hammer for that. And I'll do that over the horn and just do a series of kind of light taps, right at the root of the eye to set that weld. And then when I get to this point and I'm ready to add my high carbon steel, I want to make sure that I do a series of light, quick taps. And I start at the base of the weld. I start at the root of the weld and I work my way forward, because you want to be squishing all of that flux and all of that scale and ash out the front as you're welding. And I generally find it takes 2 or 3 heats to 2 or 3 welding passes to get a really good bond in either for for this area or for this area. So I think, yeah, at this point, I just I'll talk very briefly about a couple of alternative construction methods. I showed you this one already, but I've got an axe here. It's actually one of the few axes that I want to show that I did not make. This one is an antique that was given to me, and it appears that it is some manner of wrap and weld or composite axe. But what's really interesting about it is, it's a double bevel axe, so it's sharpened on both sides, but it has this very pronounced. You can see this is where the high carbon steel was lapped on this side. And then, there's the seam up here. So even though this was a wrap and welded axe, rather than, making a cleft and inserting a piece of high carbon steel, for whatever reason, they chose to add their high carbon steel onto the side and forge it out for a double bevel axe. In a couple of these versions that I showed you earlier, here's one where, so the collar or the socket, this part is one piece, and then sort of this piece is the piece that is sort of the body of the blade is actually L-shaped. So this piece had a little tab that runs all the way to the bottom here, and this piece was just sort of wrapped around only till about there and forge welded all along that seam. So, and then this was split, and a piece of steel was inserted into that cleft, and then of course there's another cleft and another piece of high carbon steel inserted into just the bit into the edge.
I want to ask, what type of steel do you use for the edge? If it's only a high carbon steel or is something more exact? And for the body of the axe, do you use only mild steel, or you can use some other type of steel to make it stronger, or I don't know for what reason?
Totally. So for most of my axes these days, I'm using a steel called 80CRV2, which I think maybe Patrick can speak to this. I believe it's a Finnish steel originally. I think they call it Finnish saw blade steel, but it's a okay. It's about I think it's about points. It's got about 7 points of carbon, and then it's got chromium and vanadium for some extra wear resistance, edge retention, and toughness. And then as far as the body of the steel, yeah, for the most part, I just use regular old weldable steel. Here in the States, we call it A36. There may be a different designation for it in Europe. I don't know.
Yeah.
There's a version of mild steel that is a little bit more money, and it's a little bit harder to come by, which has a little bit less alloy in it, and that would be 1018. I assume they would call that C18 in Europe. But I'm just guessing. But yeah, for most of my axes, I'm either using A36 or, as I mentioned, sometimes I use wrought iron. If you were wanting to make something that was like really, really tough, if you were making like a fireman's axe or something, and it made sense to, for the whole axe to be stronger than you could get out of mild steel, then a really popular choice would be like something in the 41 series, 4140, 4150.
Yeah.
Sounds a bit like familiar what we have been. We have done similar X in school, and I think we had similar steel for the bit.
Cool.
Yeah. Yeah, if there are no other questions at the moment, how it a bit looks, I have a question. In this Harvard Berglund, The Art of Forging, I have been reading about this, making this steel, like making these wrapped axes, or basically these composite axes, as you called them. And he said that if there is a difference to making them out of one piece, one has to ask someone who has been using both, like the laminated and the mono. And I have found so far no one but you. And I would be very interested if you have come. I don't know how much you have been using these axes you made, but if people have told you that there is a difference or you have noticed one yourself.
Right. So let me first, put the caveat in that I probably spend a lot more time forging axes than I actually do using axes. So I'm probably not, an expert, but um, when one goes to the hardware store or a big box store and buys an axe off the shelf. Now it may be different where you are because I mean, Fiskars and Groundsforce are right there, but here in America you know, we have companies that it's like, oh, they make hammers and they make shovels and they make rakes and like, oh, and we'll throw an axe into the mix too. And usually those axes are there's a compromise going on because they want something that's going to be tough enough to hand up to whatever kind of abuse somebody who doesn't know what they're doing is going to mete out on it, but still have enough, edge retention to, be used as a tool. So um, I'm not speaking about everybody, and I'm not really trying to throw shade. It makes economic sense, if you're a big axe manufacturer to make an axe out of something that is a little bit tougher and may not have the edge retention of say an 80 CRV2. So in my experience using hardware store axes, I find that they dull out faster. They're very, very tough. I mean, you can use them as a sledgehammer. You can probably even use them as a wedge to some degree. Again, that's not what they're for, but you can. Um, but what I find is, if you were trying to do something that required a degree of fineness, if you were, trying to hew a beam, if you were trying to do, some sloyd and carve out a delicate spoon bowl, um, you would just find that they would go dull more quickly than something that had a higher carbon steel edge.
Hmm.
Does that answer your question?
Kind of.
Okay.
So the real difference I was wondering about is it's a bit same that with hammers, blacksmith hammers, for example.
Mhm.
Some people say that if you have like a softer steel, mild steel body
Mhm.
of the hammer or of
Yeah.
the axe, and the ends are tougher steel.
Yep.
That at least with forging, I know some people swear it's much better because it transfers less shock.
Yeah.
I have not felt this with forging, this I can say.
Okay.
And I was wondering how, if any of these, I mean, you seem to have customers who buy these axes
Mhm.
explicitly from you, or you have made your own experience with this, if there is a difference.
Yeah. Well, I can actually speak to the hammers because I have made both mono steel hammers and composite hammers that were made from wrought iron and had high carbon steel ends. And um, I'm with you, to be perfectly honest. If there was a difference, I couldn't really feel it. It was cool, I mean, it looks cool when you show up to a meet and you have a wrought bodied hammer and you can, see the grain of the wrought iron. And to be perfectly honest, that's the biggest reason that I occasionally use it in axe bodies is because, when I grind it and then I etch it, you can see all that, that silica slag. But, functionally, does it make a big difference? Probably not. Not that I can tell anyway.
Okay, this answers my question perfectly.
Okay.
Thank you.
Yeah, sure. Yeah, I'm not gonna stand up here and tell you that like, no, a composite axe is the only way to go. Like they're vastly superior and like, no, no. I mean, no.
Well,
I mean, I
if
think
this would be your personal experience or experience of your customers, this would
mhm,
have been now, like, for me, some
sure.
revelation.
Well, and so, I mean, what I was trying to express before this, one of the reasons that I personally really enjoy making composite axes is because it allows me a lot more uh what am I trying to say? A lot more versatility of shape, I can buy one size of steel, and I can make an axe like this, and I can buy one size of steel and I can make, an axe like this. It's just a matter of like how many pieces, it's all built up. But the edge steel is still just this, it's just this little bar. I don't have to buy, great big, plates or bars of 80 CRV2, which would be prohibitively expensive. And again, I mean, if somebody wanted the challenge of trying to build something like this out of a single bar of steel, I'm sure there are people out there that could do it, that have great big power hammers and great big hydraulic presses. And, and I'm not going to tell you that, well, mine is superior because it's made from, mild steel. Like I'm not saying that. Like, I'm sure, if you were to make this whole thing out of a piece of 80 Sierra V2, like, it would be awesome. Like, I'm not saying mine's better. I'm just saying that for me, as an individual smith in a small shop, making composite axes makes a lot more sense, because I'm not just making, this axe over and over and over again. I'm making this one today and this one tomorrow and, this one the day after that. So, I guess my ethos, my thinking on the matter is that, once you sort of cultivate those skills, once you're comfortable building up axes out of multiple pieces, you can, create a lot more styles and in a much bigger size range than if you're always starting from, an individual block. So, and then, and to be perfectly honest, the other part of the reason that I do that is just purely the romance of it. I really love forge welding. I love when you pull something out of the fire and it's, sparking and glowing and you hammer it and it fuses. It just, it feels like magic. And I feel like this sort of like, kinship with the smiths of yore, who that was really the only practical option, getting big bars of steel to forge an axe blade out of just wasn't, it wasn't a thing. Everything, no matter how big it was, whether it be, a 2,000-pound ship anchor or, something of that scale, that was just built up from little pieces, because that was what they had the technology to do. And, and I like that aspect of it too, that kind of experimental archaeology.
Oh. Yeah, thank you. This was a very extensive and fantastic answer.
Oh,
Good.
thank you.
I want to ask, after you folding the axe and you weld it, you how you shape the eye, then you drift the eye to make a.
Correct. Yeah.
Okay. And
Yeah,
after the welding, how is the shape of the eye? Is like, because you showed some drawings before of the eye.
Right.
So after the weld, the eye is more like, I don't know. Yeah, that's what I know. Yeah, it's after the welding is the top or the bottom after the weld.
Well,
It's in between because you said to be a 90-degree or something.
Right. You want, what you're looking for is this little bit, right at the end.
Yeah.
You really don't want that to be pointed. That is much more likely to propagate a crack, than this. So, so ideally when you fold it, you really, you just need to sort of drop in the drift and give it a couple little taps here and here, and then you've got your shape, as opposed to, so in theory, if everything were to go perfectly, you might not even need to drift your axe. I just am not that good. I generally find it necessary to go back and clean up the shape of my axe again. Oh, and one other thing, without getting too far in the weeds, is that I often add a steel pole to my axes too. So this is, a piece that was wrapped and welded, has a carbon steel bit, but then it also actually has another little piece jump welded onto the back. And that, it builds up a little bit more mass, so it gives it a little more meat back here, but it also then you can, more effectively use that as a hammer if you need to do that. And where was I going with that? Just that when you do that, you often upset the eye a little bit, and then so it makes sense to go back and drift it. And pull that back out.
And the other question I want to make is, if you weld a piece on the back of the axe, is this a tool steel or is again mild steel?
Yeah. So this is 1045. So it's like hammer steel. So it's
1045. Yeah, I know.
Yeah. Or C45.
Okay. So you use something that can be hardened on the hill of the. Yeah.
Correct. Yeah.
Okay.
Yeah. I don't.
Thank you.
It doesn't need to hold the keen edge that the bit
Yeah.
does. But I think it. If you're gonna do it, you might as well use something that can make the can expand the versatility of the axe.
Yeah. Thank you.
Sure.
Okay. Sandra Bauer, you're also raising your hand.
Yeah, so you're now showing to weld on that bit
Yeah.
at the end.
Yeah.
Why would you not weld that on while you still have the thing still flat?
I have tried it both ways, and for me, I find that I get a much cleaner, tighter weld if I do it afterwards.
Okay.
Yeah. So actually, I have. Yeah. So this axe right here was one of the very first ones that I ever added a forge welded hole onto, and I did it, kind of like this. When it was flat, I put that piece of high carbon steel on there, and I forge welded it in place. But what I found was when I bent it around, the edges popped off. And it wasn't a huge deal. I was able to flux it and re-weld it, and I got, I don't know if you can see, but there's a stamp design here, so it's kind of hard to see, but it ultimately welded very well, so it wasn't, it turned out to not be a problem. But
it's a stress point.
Yeah, exactly. I just found that when I bent it, that was asking an awful lot of the weld, and part of the weld sheared off anyway. So if I just wait until it's already wrapped and then jump weld on my steel, it seems to work better.
I just have a question. When you were talking about folding the axe, the eye, you said sometimes you had a little bit of carbon steel in between in the eye.
Yes.
I'm just wondering why, and why wouldn't that little piece of carbon steel be like kind of a wedge and splitting the axe more easily instead?
Interesting point. So in my humble experience, which is, I don't claim anybody else's, but in my humble experience, I find adding that little shim of high carbon steel makes my weld stronger.
Okay.
I don't know precisely why that is, but
would it be because the welding temperature is lower on carbon steel?
I think that's a big part of it.
Yeah, right. Okay.
Yeah. I also just think that for whatever reason, high carbon steel sticks better to mild steel than mild steel sticks to mild steel.
Yeah, right. Okay. Thank you.
Sure.
Maybe then it's now a good time to close this for today. Thank you, Nicholas, for preparing this presentation. It has been very informative and fantastic. And even though we have been forging axes in school, I have learned a couple of new things, and I hope this is true for everyone else here. It was really, really cool presentation. Thank you.
Thank you.
If you like what you have been seeing today, there are two major ways how you can help with that this project continues. One is you give a Treff presentation yourself. This might seem significantly more difficult than it actually is. And as I said in the beginning, almost everyone, I think even everyone who has been giving a Treff presentation has said afterwards it was a pleasure to do it. And I can also speak from experience. I also liked it a lot. I like a lot when I learn more while I talk about something. And I also like when others talk about something, I can learn from them. So this is, and probably most of you have it similar. So it's a win-win situation. The other way, there's also a link to our Ko-fi page. This project is very much voluntary work. Like these people who give these presentations, they do it voluntarily. I do most of the work. I do actually everything I do here is voluntary. Same goes for Paul, and same goes also for Mariano. But we have running costs, like a Zoom account and the web server and everything. So if you find it helpful, it would be very cool if you consider a small donation, even a month, even just like €3, €5, or put in the dollar or whichever currency you are, whatever small amount. in the big picture makes that we can continue this project. So it's very much appreciated. Some of you might have heard about Forging Through Time. It has been an event which is, the idea is that every smith forges in their time zone from 2 to 5 o'clock, so for 3 hours, on a topic, on a project which is this time about the topic quality time. The first time it was just time, the second time it was stretching time. You can see the pictures of the pieces on the Forging Through Time Facebook page. Really cool stuff. And we are doing this again this year. It's happening in October on the 18th. And the invitation will go out soon. The official invitation has actually partly already gone out, but things are a bit slow for me at the moment. So if you find it interesting, the idea is every smith is in their time zone at this, zooming from their workshop, like there is a big Zoom link and everyone zooms in and like links in like you do now, but you're in your workshop. And the cool thing is while the other people are working, like while you are working, other people can watch. And while other people in other time zones are working, you can watch them. And from having this event 2 times and being also on both sides, it's really cool to see others work and look into other people's workshop. And it's also very cool if other people can look into your workshop and then talk to you. Hey, what is this tool which you are having there at the side of your anvil, which you use frequently? I've never seen it. And it's yeah, it has also been very nice chat. So if you are in the time, in actually whichever time zone, we had also some people from Australia dropping in, some people from California. So we had basically the full spectrum of time zones there is. If there are like this would be it from me for the official part. I will now stop the recording.